Any grieving Patriots fans out there? Too soon. It's not too soon for us Patriot haters, I'll tell you that. Sorry. So what you got? Say again, sorry?
I got confused on the control group, placebo, and blind on number 87.
Oh, okay. So who did that problem? There's blinding and there's double blinding, which sounds horrific, but anybody know what those terms represent? Anyone done their 1-4 homework for real? No? Nobody? Oh, I love you guys. At least you're honest. Yes?
Isn't blinding when, like, the groups of people don't know if they're placebo or not, and then double blinding is when the experiment, like the people getting tested and the tested?
Yes. So why do you think, so double blinding means the people involved in the study don't know what they're getting, which kind of makes sense. You kind of don't want them to know. Double blinding means not only do they not know, but it's set up so that the people running the experiment don't know either. Now there's a way they can see it afterwards, they can break apart the data. But while they're doing the experiment, why do you think it's important to not let the people running the experiment know who's getting the real drug, who's getting a placebo? Why do you think that would be something to worry about? Yeah, so that their own hopes or beliefs, they can't influence the data either. Right, so that's why you want to have double blinding sometimes.
Oh,
I like it. Yes?
I have doubts about continuous, quantitative continuous.
Say again?
Quantitative continuous.
Oh, continuous versus discrete?
Yeah.
But real quick, your question was about the control group too? And
How would you know which?
so in this example they give you, in numbers 87, not every term relates to it. So don't look at it like, let me look at every term and try to find what piece of this. They're not all going to be a part of this. So in this problem, I don't think let's see. Yeah, there's no control group, right? There's nobody, everybody is tested twice. There's no control group not getting the sleep treatment, the sleep being different. There's no control group.
Well, the answer is the sense of the control group is the group is split from one.
So I don't think, let me see. Each driver participated in 2 experimental sessions, one after normal sleep and one after 27 hours of total sleep deprivation.
Because I didn't think there was one, but
I guess you could argue, see, from my standpoint, it was they both got both treatments, so there's no control group. Because you can argue that the data they collected before they had sleep deprivation would be like the control group, the baseline you could set up. So you could argue that. No, I just need enough of the terminology from section 1.4 to show up in your explanation. So some people don't read 1.4 at all, and they're using sample population, old news, words. I need section 1.4 words. I need kind of like enough of them. Not all of them are going to work. I like it. Anything else from homework stuff? Yes?
Later I need you to help me find 12 through 23 for 1.3.
No. Okay, so, again, do the numbers. I added 12 through 23 in later, and when I went to add it on my homework sheet, I put it in the wrong section.
Oh, so it's actually like...
Yes, so I don't care where 12 through 23 are. They are signed. Do them.
Okay.
I love it. Just go by the numbers I assigned. I think that's the only place I did that. I just decided to throw it in there and just put it in the wrong section.
Yeah, that makes
Yep.
sense now.
I like it. Okay. I love you guys. Don't wait when you have an issue. We're a weekend. We're more than a weekend now, really. So, I mean, I got some emails about how do I find the homework, and I'm like, oh my God, okay, you're supposed to have been working on it already for a while, you know. So don't hold back. Don't sit on it. It doesn't make any sense. Just let me know immediately if there's something freaky. All right, you can email me. I check my email off and on throughout the weekend. Okay, anything else from homework stuff?
Yeah, my question.
Okay, yeah.
The discrete versus continuous.
All right, so age. Somebody's age. Would that be discrete or continuous?
Discrete.
So I don't care how you normally say it. It's what could it truly be? What's the truth? So I would say I'm 45 years old. What's the truth? I'm probably 45 point something years old. Now, as humans, we decided just to say the 45. Does that make sense? If I was 45 years and 6 months old, I would say I'm 45 years, but I'm really 45.5, right? And little kids know this. I'm 3 1/4 years. You know, they kind of break it down because they're like, I want to get older. What the hell? And then when we get older, you're like, I'm going to be 40 for a while. Don't work. Sorry. So the continuous and discrete has to do with what could the value be, and it still makes sense. So if I said number of doors on your car, that is not continuous. Would 3.92466 doors make sense? No. But would 3.92466 pounds make sense for the weight of a bag of sugar? Yes. Yeah, you can measure it more and more precisely. But you can't measure the number of doors in your car more and more precisely. Do you see?
It's all about precision. It's all about
It's all about how precise could you be. Are there numbers that you have to skip, or would you use every possible number and it would make sense?
Like how many bottles you have on the table?
Yes.
Versus how much is the weight for each bottle?
Versus, how much does this weigh? Well, I could take on any value between 0 and whatever. But the number of bottles, I don't care if I've drank some or not, it's still a bottle or it ain't. Right? You guys?
So the number of bottles will be a discrete?
Totally, because it's countable.
And their weight can be continuous? No?
Would be continuous, period. Not can be, but is. Yes.
Okay.
I like it. So even if I say that kid is 17 years old, he rounded to 17, it becomes discrete. No, that's crap. It's all about what could it be. We as humans, we decided, not to say 17.3846. Whoa, dude. And what time is it? 7.77? No. We decided just to round it off, but what could it be? Not just the way we decide to show it, but what could it be?
So if I ask you about the time, like something related with the time, it will be mostly continuous, right?
Yeah, if you talk about true time, right? If anybody ever watches any of those shows on YouTube where they slow things down, the slow-mo guys, have you ever seen any of those? You should look them up, it's good. But, you get slower and slower camera speeds, and then you start to realize, you can cut time down more and more and more and more. All right, so I'd say that's continuous.
Okay.
Yeah. Now, if I said, time as shown on a watch, well, then that's discrete. As shown. Is it possible for the watch to show you every possible value of time? No, it stops. It kind of says, my screen is only this big, dude. It's not infinitely big, so. Yeah. Okay. All right, maybe. Anything else from homework stuff? Okay. All right, I'm going to be an optimistic fool and take that as a good sign. If that means that you haven't done much homework yet, well, that doesn't make much sense. We have a quiz coming up on Wednesday, remember? It's going to be on Chapter 1 and Section 2.1. It's going to have all the definition stuff.
Section 2.1?
Yes. So we actually got up to 2.3 last time. But 2.1 is actually just stem and leaf plot. Yeah. And bar graph, sort of, but I didn't really make you do any of those.
So we're doing the front and back. That's the quiz. 2.1 and 2.2.
No. Let me try. So Chapter 1 and Section 2.1 is the quiz on Wednesday.
How is it Section 2.1? If 2.1 is already Section 2.
The quiz is going to be Chapter 1 and Section 2.1. Is that okay?
Yes.
Good Lord. Yeah. So as a math teacher, I know some things are difficult to explain, but you gotta meet me with the things that really aren't. You gotta meet me there, please. Okay. All right, I'm hopeful. Okay. So no other questions? We're gonna jump back into where we left off. Okay. So last time we did end up finishing that handout I gave out with the histogram that we made. Cool, I like it. If you weren't here, I have a few extra. Anybody didn't get that? I have 3 extra. Let me find out. 3 hands I saw. Oh, there's a 4th one. Let's do that. Yeah, just hand up 40, though. All right, so if you didn't get that, you can email me. I can send it to you. No worries. And you can watch the video if you want to see us do it, right? Okay. So we left off 2-3. Let's see. Oh, we're about to get into 2-3. Put you away for now. All right, so I want to warn you guys, this section there is a really kind of complicated little formula for doing a certain thing that I don't use. I don't. I give you kind of a different way to do it. If you don't understand why it's okay to do that, and you just want to do the formula in the book, feel free. That's fantastic. Formula works, but it's just too specific. Hopefully after today's discussion you'll see what I mean. It might make sense that statistics is the branch of mathematics where there's kind of the most disagreement. And for students it's funny because you're like, how can you disagree about math? X equals 2, you know. But real math is not that concrete, and statistics is the one that really shows you in your face, hey, we're not sure about this. We think it's this, give or take 2%. Right, that's built in. You guys with me so far? I mean, that's built into the stats, right? Because we only look at a sample, and then we make guesses about the population based on our sample stuff. All right, I like it. So there's a little bit of disagreement with some of the stuff we're going to do in this section, but the idea doesn't change just because you have a different way to calculate something. So what we're about to get into is we talked about how to represent data. Now we're going to start getting into how to analyze it mathematically, how to get some results from it. Very preliminary, basic results. Anybody taking the SAT? Do they still report stuff in percentiles, like to tell you you're in the 90th percentile? They used to. Does that sound familiar? What the hell is a percentile? And like, if you scored in the 90th percentile in the SAT, do you think you'd feel good? That sounds right? I mean, if you scored 90% on a test, would you feel good? Yes. But does 90% on a test mean the same thing as the 90th percentile? No. 90th percentile means that you scored higher than 90% of everybody else who took that test. You guys with me? So if I was in the 12th percentile of golf scores, everybody know how golf works? A higher score is bad. So if I was in the 12th percentile of golf scores, would I be happy or sad? I'd be happy. I got a very low golf score. I took less strokes, and I don't play golf, if you could tell from I play like putt-putt golf at the most. Right? All right, so if I was in 12% of golf scores, I would be happy. So it kind of depends. You can't always say 12% is bad and 90% is good. It depends on what you're looking at. Okay? So a percentile means that percentage is below whatever that value is. So if I paid so much for my car to get repaired, and that was the 85th percentile of car repairs costs, would it be happy or sad? What would that mean? That was the 85th percentile of car repair costs. That would mean that I paid more than 85% of everybody else. I would not be happy, right? That would suck. Is it because of my cars? Because of the accident? What was it? All right, maybe. So let's get into how to calculate this thing. And if you've never seen it before, your first guess is going to be wrong, which is fine. There's nothing wrong with that. We have to get into why it's wrong and see why it makes sense. so you can see. Let me make up some data here real quick. I'm going to be really nice with this data. Anybody see how I'm being maybe nice? Huh? Yeah, it's in order already. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
What section is this?
2, 3. Sure.
Chapter 2 or chapter 1, section 2?
Section 2, 3.
Chapter 1, section 2.
Chapter 2, section 3. So section 2, 3. I love you guys. This is going to be exciting. It's going to be a neat semester. What's your guess what value would be the 80th percentile? So understanding what this means. And we represent 80th percentile, the symbol we use, because this is way too much writing for math people, is P80, like that. That means 80th percentile. So that symbol, you're going to see it a few times this semester. It always means, when you have a P with a subscript number, that means that percentile, the 80th percentile in this case. Somebody give me a guess as to what the 80th percentile. There's 10 numbers up there.
38.
I have a...
41 and 45.
Okay. I have... Give me the number.
38.
38?
Yeah.
And then I have a 41 and a 45 somewhere in there? 31? Okay. So remember, 80th percentile should have what percent of the data below it? 80%. Now 80% of 10 is 8. So one of these guesses is decent in that way. 1, 2, 3, 4, 5, 6, 7, 8. So this has 8 below it, right? That's not the right answer, though. Because the 80th percentile should have how much above it? 2 in this case, 20%. It should have 2. So if you do that, then you think that's the right answer. But we already know this can't be the right answer. So what we do,
You get the number between those.
yes, you get the average of those two. Isn't that number going to have 8 below it and 2 above it? Okay, I like it. Everybody kind of see the reasoning behind that idea. No? What's up? So again, if you think the right answer is this one, because there's 8 below it, it only has 10% above it. How could it be the 80th percentile? If you're in the 80th percentile, 80% below you means how much above you? 20%. So you have to have 8 below you and 2 above you. And the only way to do that is to get the number in the middle of those two.
Like which one?
If you average those two, what do you get? If you average those two numbers, add them up, divide by 2. Yeah, 39.5. You could also say they're 3 apart. They're 3 apart and cut that in half. 1.5 up from 38 is 39.5. How many numbers are less than 39.5? 8 out of 10, 80%. How many numbers are more than 39.5? 2 out of 10, 20%. So 39.5 does have 80% below it, 20% above it. And what part of that doesn't jive? Let me know. I see some faces that are telling me that question needs an answer. What part of that doesn't make sense? Please tell me.
Wait, what did you divide by?
To find the middle of two numbers, you take the average. And how do you average anything? Divide by how many there are, right? The other way to do that, please let this make sense. Aren't they 3 apart?
Yeah.
So what's the middle number? 1.5 away from one side or the other? If they're 3 apart, I just go half that distance, which is 1.5. 38 plus 1.5 is 39.5. I like it. Okay. So please tell me,
Is it always a decimal then?
no.
No?
Mm-mm. Sometimes it will be an actual number. And I want you to realize something. All right. I'm trying to get the basic idea understood. This is a very small sample, though. To be really honest, P81 is also 39.5. There's only 10 numbers up here. There's only so many things for any specific percentile to be. So when do percentiles actually make full sense? Like they exactly match when there's a large sample. Big ass sample.
50.
So what I want you to understand right now is sometimes I'm going to have to go between two numbers, and sometimes there's going to be an exact number that's the answer. So there's two possible things, right? And it's going to relate to the steps we take to actually calculate a percentile. So P80 here would be 38 plus 41 divided by 2, 39.5. Right. So what did I do? I took the 38 is the 8th number and the 9th number, and I averaged them, right? Okay, so let's make a process here. Actually, let me ask you this. Let's see, I don't want to say this. Oh. Well, let's do this. What's 80% of 10? Because that step makes sense. That's what everybody gave a guess, did something like this. If I want to get to the 80th percentile, I'm going to go 80% of the way into the list. So 80% of 10 in this case. It isn't always 10. If I had 20 numbers, I would do 80% of 20. So in general, it's going to be that made as a decimal times n, the sample size. I want to go that far into my list, as long as my list is in order. Okay? How are we doing so far? Why does the list have to be in order?
You're still going to teach us how to put it in order on our calculator, right?
Say again?
You're still going to teach us how to put it in order on our calculator.
Of course. Yes. It's part of what we're going to do today. That's why I brought my little cooler of calculators. Yes?
Why do you have to find the average?
All right. If I ask you what number is in between two numbers, how could I find that?
I know how you found the average, but why did you have to do the in between numbers?
Oh, all right. Because it's compromise. Both of these are right in one sense. So 41 is right because it's got 8 numbers below it. 38 is right because it's got 2 numbers above it. So what is right? Right, the thing in the middle of those two. That's going to have both of those things true at the same time. I like it. And it's only when you have a very small sample that this really gets confusing. If I had a really big sample, there's enough numbers so that every percentile has a number that's associated with it from my data. So when I have a very small sample, it gets a little bit weirder. Okay. So here's the process. The first step is to do this. 80% of 10, or whatever percent of n, however big my list is. And that, of course, is 8. So if it comes out to be a whole number, sounds like a note because we're going slow. So if it comes out to be a whole number, you average that one with the next one, which is exactly what we did. Came out to be 8. That means I averaged the 8th and the 9th ones together. Why? For the reasons we discussed. So this means the second step then is P80 equals average 8th and 9th number. And that's going to be 39.5. The work we did up here. So those are the two steps. How deep do you want to go? Go that deep. And then look at the number. Now we got to still talk about what if this is not a whole number. So let's do another example with the same data. There's only 2 things that could happen here, which is nice. So this is all for P80. What if I wanted to find P, what you got, Jeff? P72. What's the first step going to be? Yeah, 72% of 10, 0.72 times 10. Real quick, why is it of 10? Because there's 10 numbers, so don't always do 10. I always get somebody to do their homework and they're always doing 10. No. If there's 87 numbers, you better do that percent of 87. Whatever, how many numbers you have, that's how deep you want to go into the list. So what is 0.72 times 10? You multiply by 10, you just move the decimal over, right? 7.2? Now, if it comes out to a whole number, I average that one with the next one. If it comes out to anything else, you round up and take that. So it came out to 7.2, I round up to 8. The 8th number is the answer. So P72 equals 38. Now, really, I want you to realize, and again, I really want you guys to understand, this is a rough idea of placement. Where are things in my data? So, notice P73 would also be 38, wouldn't it? P74 would be 38. P75 would be 38. P76 would be 38. And why is that not a concern? We only got 10 frickin' numbers. There's got to be some repeats. There's only so many numbers that each percentile can get. So don't freak out about that. When you have a larger sample, then you can get better resolution. What's up?
Why didn't you round down instead of go to 70%?
Because then it doesn't have as much as it's supposed to have below it. And that's the one that's slightly more important.
So do you want us always to round down?
Yes. This is the two steps. If it's a whole number, average that with the next one. If it's anything else, round up and take that number. I like it. Now, real quick, let me show you an example. And this is something called the median. We're going to talk about it later. But it's P50. If I had 5 numbers, why is P50 easy? What's the middle number if I have 5 numbers?
3.
This one, right? Well, what's half of 50? I mean, what's half of 5?
2.5.
2.5. Then I round up, take the third number, that's the answer. See, it matches up with what we knew should be true. What's the middle number? Well, if you have 5 numbers, it's got to be the third one in. If I have 4 numbers, what's the middle number? Well, what do I have? If I have 4 numbers, I have 2 that are in the middle. So what is the middle? The middle of the 2 in the middle is frickin' middle, right? Not middle, sorry. So you average the 2 in the middle, and that would relate to what's half of 4? But like 50% of 4 is 2. Average the second and third. Hey, that matches up with the idea. So these are all kind of related. The smaller the sample is, the less specific it is, the more repeats you're going to get, because you just don't have that much data to choose from. So that's one reason why the formula they use in the book is so silly, is because when the sample is really small, it really doesn't matter to be that specific. And when the sample gets really large, the way I do it and the formula match pretty well. So that's why I don't really worry about the formula they have in the book. Okay. So let's do this. I do have a handout I'm going to have you guys work on here in a bit. Let's use the same data. And let's talk about something related to, I don't know, anybody watched the game last night?
Yeah.
A few of you guys? I'm
We're
sorry.
doing the homework.
Sorry?
We were doing the homework.
I'm sure everybody was. I'm sure. You could do it in between the Patriots getting spanked, but sorry if there's any Patriots fans. Not really. So, of course, how's a football game or a basketball game or anything else like that broken up? It's broken up into 4 quarters, right? So, and they're kind of important. They tell me after the first quarter is done, in a way, there's how much of the game done? 1/4, 25% is in the books, right? And so forth. Are you with me? So the quartiles are percentiles, specific percentiles. So the 25th percentile, we call it the first quartile because we're so creative. Right? And then this one we just talked about. This is also known as the median, but it's P50, it's Q2, and then P75 is Q3. Take a minute and figure out these 3 for this set of data. Do the work for these 3 for this set of data up here.
Like the high low.
I'll get to it. I'm just focusing on this right now. You know where I'm going with this. Well, there's 2 steps to any percentile question. So we catch up to you, make sure you're doing this okay. P25, Q1, how do I find it? What's the first step? Yep, 25% of 10. So 0.25 times 10. 2.5, what does that mean? Yeah, round up. The third number is the answer. So then the first step is where's the answer, and the second step is go get the answer. The mistake I get is people tell me that Q1 is 3. You see what I mean? They get 3 and they stop. They're like, I got a number, it must be done. No. The third number is the answer, so 19. Pop. Yes, ma'am.
Is this kind of off topic, but for homework, would you want us to show our work like this, or can we just put it?
You better show me some work. I got a shirt that says show your work. It's kind of important. Your work is what I look at, right? This calculator, some of you guys know it better than others, and I'm going to catch everybody up to speed. But it kind of sucks if you know it too well, because it can do a lot of this stuff just by pushing a bunch of buttons. But that means you didn't learn shit. You just got answers, and you don't know why. So I don't like that. I need to see the work so I know it came from you. Yeah? Oh.
Oh, that was doing.
So what do you guys get for Q2? Half of 10 is 5. What does that mean?
25. Or 5. 5.
You got a whole number, so that means average the 5th and 6th. What's the 5th and 6th numbers?
25 and 29.
25 and 29, so 25 and 29 divided by 2. Or they're 4 apart. Cut in half is 2. 2 up from 25 is 27. Either way you do it, you get 27.
And we do that only when we get a whole number.
Whole number, exactly.
Whole number,
All right.
okay.
So please appreciate that math very often has a lot of steps. There's 2 things that can happen. Whole number, average it with the next one. Anything else, round up and take that number. That's it. That's it. I'm going to do this directly, and I'm going to show you a shortcut. So it's 7.5. It's not a great shortcut, it's only 10 numbers.
Yeah.
But still, so
Round it up.
round it up.
8.
It's an 8. The 8th number is the answer, so what's the 8th number?
38.
All right, 38. Now watch this. I already did Q1 was 3 in from the top. Q3 is going to be 3 in from the bottom. It should be. They should be kind of symmetric, right? So 1, 2, 3, freaking 38. Done. So once you get Q1, that's how far in it is from the top. Q3 is going to be equally far in from the bottom. Please let that make sense. Okay, I like it. Now, if I put this together with the lowest number, which is 12, that's amazing, and the highest number, which is 45. These comprise what's called the 5-number summary. There's 5 numbers we calculated, and it summarizes the data. So again, math people are very creative. So this is called a 5-number summary. So if I say calculate the 5-number summary, bang. Low, first quarter, second quarter, third quarter, end of game. We're high. Now you're going to love this next thing. Yes, ma'am.
I'm sorry, I got lost in the very last one.
What happened? Sorry. This guy?
45.
This one?
Yes.
It's just the highest number. The lowest number?
Oh.
25% of the way in, 50% of the way in, 75% of the way in, all the way to the highest number. That's the 5-number summary. Now, I love some of you guys are like, ugh. Get to know, etc. Something going to get you through. Now watch. This is called, believe it or not, we can construct this weird thing from these numbers. It's called a box and whisker plot. The book calls it a box plot, but its official name is the box and whisker plot. And what you do is you make a number line with a scale so that everything can fit on it. And people have a lot of trouble with scale for some reason. When I make this, it does not matter that any of my numbers show up on the scale. I just have to have the numbers fit somewhere. So to make this box and whisker, I'll call it just a box plot. I need to have 12 fit in there and 45. So it makes sense that maybe I'll start at 10 and go by 5s. So then everything has a home. Go up to 45. You guys see what I'm saying? Don't just put your data points down. This is what I get. This is a mistake. I get 12, 15, 19, or I get even worse. I get 12, 19, 27, 38, 45. All right, why is that bad? Well, this is 11 apart. This is 7 apart. And that looks the same. What the shit, right? Your scale has to be true, or else you're misleading people. So set your scale up first, and then find your data points, right? So I'm going to go by 5s, 10, 15, 20, 25, 30, 45. See, I didn't care at all about my data points. The only thing I cared about was I've got to go down far enough to get the first one, and then go up far enough to get the last one. That's all I cared about. Now here's the way to put this together. You don't put a circle or something like you're graphing in algebra. You put a line above the data point. So the lowest one is 12. It's about right here. The next one's 19. Bam. The next one is 27. Bam. And then the last one's 45. Bam. Did I forget somebody? I feel like I forgot somebody. 38. I forgot 38. So of course you should end with 5 lines. It's a quick way to do what I just did. Make sure you get everybody. Now where's the box and whiskers come in? The middle 3 lines. Slabang. There's the box. And then you go from the out to the ends like this, and there's your whiskers. Can anybody tell me what percentage of the data is in the box? It's a stupid 7 joke I could do, but I'm not going to.
50%?
Yeah, it's 50%. How do you know that? What's this one again? What is this? That was the third. What percentage is below it? 75. So there's 75% that from there to there. And then what percentage is below this? This is Q1. So what percentage is below it? 25. So what percentage, of course, is in the middle? 50. Beautiful. That's always the middle 50. If you're thinking about what college to transfer to, if any of you guys are going to transfer, you can look at, there's like college guides. There's one called the Princeton Guide of Colleges. And you'll see them always say the middle 50% of GPAs are from this to this. So what do they say? They're saying that. They're saying Q1 to Q3. The middle 50%. They're saying that's our heartland. That's our representative. And then everybody else is sort of like, in a way, kind of outside, like the extremes. So they go for the middle 50%. I like it. Now, if this was ages of people buying a certain kind of, I don't know,
Pill.
pear?
Pill. Medication.
Oh, certain kind of medication? I don't know, this 12-year-old getting their own medication. And I had another box plot with the same scale. You can compare the two, right? The second plot seems to go for older people, right? That's a quick one. Which one of these varies more? This is kind of a harder question because of this long thing. But you see how you can look at this, see the middle is so much tighter here, right? So there's 50% in that little middle, so it doesn't really get away from the middle very much. Whereas this one is bigger. It's kind of more spread out, right? So this is a quick visual. This was relatively quick. This is a quick way to visually represent data so you can compare them very quickly. Okay, I like it. That's one way you could use this. Okay, that's not too bad, right? 5-number summary, box plot comes right off of there. I like it. No matter what I say, you guys look so worried. Okay. Just got to try that out. That's section 2.3. Oh, before we get out of here, there is something related to this, guys, called the interquartile range. Interquartile range is just Q3 minus Q1. You see how that's related to the middle, the heartland, the 50% heartland. So what's the interquartile range for us? Well, it would be 38 minus 19. It's 19. That's how wide the heart of it is. The range is high minus low. The interquartile range is Q3 minus Q1. How widespread is that middle? 38 minus 19 is 19. 38 minus 19. I like it. Yes?
You lost me on when you were drawing your box. You just connected them. Is that what you just
Yep.
did? Okay.
So, I mean, I just see. That's all I did. Those are the Q1, Q2, Q3.
Okay.
And then you just draw top and bottom to it, make another box.
Okay.
Yep.
Thank you.
Mm-hmm. So I'll tell you what, I'm going to let you guys can do this side of it, the one that relates to percentiles. Don't worry about the back yet. We haven't talked about that yet. I think the first thing I'll do is I'll show you how to sort in the calculator. Yeah. You need to borrow a calculator. Come on up. Bring an ID with you.
Crazy.
You don't have an ID, then you don't get a calculator. Shirt turns on. Shirt turns on. Oh, God. Okay.
You know what's best?
That last row over there. Are you in that last row? Take a big favor.
Like that. And then after the each, I don't understand that. Just put some.
Make sure it turns on.
Yeah, but what's the?
What's up?
After the
In the
each,
homework
there's
file?
something here. I don't know. Something like this.
She's got battery.
That's the highest number. Highest number.
And then the other one is what, number one?
Turns on.
What is that? After the,
It's a symbol for number.
but after that, he has something there.
Numbers.
Yes?
Numbers.
Oh my gosh, look at it.
Oh.
Let's see. Two left.
That's how you do it?
Maybe they work. Make sure it turns on. Make sure it turns on. That's just
I don't know how I didn't know that. Because
Something you'll always
Don't bank on having a calculator. Don't. Because I have an office mate that uses these calculators too. So, yeah, if you don't have a calculator yet, you should get one. But if you absolutely can't, I will bring them with me. If I was you on the day of the test, I'd come early and say, hey, can I borrow a calculator right now? All right. Order here. Guys, even if you want to sort it some different way, just hold on. Let me show you how to sort. Because when you get big old listed numbers, you don't want to spend time sorting it yourself. My God. And this is a nice way to get used to how to put data into the calculator. There you go. How you been doing? Blazing speed. It's bad for you, can't get this program. Let's see. Aw. So, hopefully it makes sense. What's the most important button on there for us besides on? Stat. Yeah, so everybody hit stat. This edit is where we're going to put stuff in. Calc makes sense, is where we're going to analyze data once we have it in. Sort, self-explanatory. Why is there two of them?
Ascending and descending.
Beautiful. Ascending, descending. Clear list does that. And setup editor is if you go to your lists and some are missing, like they're just gone. Like there's no list one, or somebody named it Fred, because you can rename the lists. Just go to setup editor and it brings it back to normal. What is normal? Normal, if I hit enter for edit, I should see this. So please do that. Anytime we do something in the calculator, please do let me know if something weird is happening for you. Everybody good so far?
No.
What's up? Hit stat.
Oh, yeah.
And then edit. Yeah. Everybody else okay? Oh, okay, don't worry. Besides that, is everybody else okay? Yes, ma'am. Oh, you got it? Okay. So it's right here. Right there. Okay, so if you have stuff in your list, here's what you don't want to do. You don't want to go up to the list and hit delete, because then the list goes away. You want to hit clear, enter. So if you do that, so if I had stuff in here, 5, 6, and I went clear, enter, bam, it's gone. Yay. And the list doesn't go away. Thank God. So there's a lot of things that default to list 1, so it's nice to have list 1 there. So you can just hit the button and make it go. Are we all good? Oh, you gotta hit clear, enter. Did you go up to list? You got it? All right. I like your case. Amazon's got everything. Yes? So you go up to L1, you hit up, and now hit clear, enter. Clear, enter. Okay. Everybody else good? Good. Okay. So let's all put these numbers in there, right? The ones in the box up here. That's the side we're doing, the percentile side. Just all put them numbers in there. Once you get them in, I'll take a quick look through, make sure everybody's got 2 digits at least. It sucks when you sort it and there's a 7, and you're like, there was no 7. Oh shit, which one was the 70 what? Oh shit. Then you have to kind of figure out which one was it you left something off of. Everybody with? And make sure, let's see, how many data points are there? 5 times 4 is 20. That's amazing, Jeff. So make sure the last filled in spot is the 20th spot. See that? The 20th spot? Maybe we should take this back up to ginormous size. See, that's the 20th spot. Sometimes people freak themselves out because they're here. Like, I got 21. No, you don't. That's the 21st spot it's in. So you're good. Okay. I like it. Everybody good so far? I like it. Okay. So then you hit, not surprisingly, you hit stat. We almost always sort ascending from smallest to biggest. Sort ascending. Now this is going to be, gotta be careful. See how it's got that parenthesis? So it's waiting for input. Like a function f of something. So you got to tell it which list you want to sort. And I don't know how many of you guys have not used this much. Not everybody's filled in that survey for me. But the second button's like a shift button. And L1 is above 1. See that? L1? Right there. So if you hit second 1, it'll tell it list 1. Sort list 1, and then it's very anticlimactic. Done. You're like, okay. So then you go back in. Has everybody done that? Is everybody good with that? Anybody getting errors? Yeah. Everybody else okay? Second one. There you go. Now if you go back into your list, it's like magic. Cool. So it's all sorted. So now you can do that worksheet. You guys can work together if you want to.